All right, so today we're going to finish our integrals using trig substitutions. This is the second day. Yesterday we worked on integrals of the form when there's a square root of a squared minus x squared in your integral. We will make x equal to a sine theta, and then our square root of a squared minus x squared will become a cosine theta. We'll do something similar today, but in this case we're looking for, instead of a minus x squared, we're going to look for a plus x squared. We're going to use a similar substitution, only instead of sine, we're going to use tangent. All right? And so if I think about doing that, I get a squared plus a tangent of theta squared, which gives me, if I factor out my a squared, 1 plus tangent squared theta. And using this identity right here, this becomes square root of a squared secant squared theta, and the square root of a squared is a, and the square root of secant squared theta is secant theta. And so that's what will happen when we use this substitution in our problem, and it will make it, hopefully, much easier to substitute, or to find an integral. So let's look at an example. Here's an example, dx over square root of 49 plus x squared. So I notice right away I have a number plus an x squared, and I think x is, we said, a tangent of theta. My a in this case, remember this is a squared, so a is going to be 7. So I'm going to set x equal to 7 tangent of theta. I need also to account for dx, because when I substitute in, I need to not only replace the x, but I need to be able to replace the dx. Everything about x needs to be replaced with something about theta. So if x is 7 tangent of theta, dx will be 7 secant squared theta d theta. So now let's do our substitution. Dx gets replaced with 7 secant squared theta d theta. I have square root 49 plus 7 tangent theta squared. And as I said yesterday, at this point, given what we did on the last slide, I can just replace this part right here, right, is going to turn out to be 7 secant of theta. So my next step, this becomes 7 secant squared theta d theta over 7 secant theta. My 7s will cancel, and one of my secants on top will cancel the secant on the bottom. So my new integral is secant of theta d theta. And when you say, wow, that's sort of like one of my integrals, but it's not one that we actually know. This is one we did earlier this year, and it requires a little trickery, a little what I like to call math magic. So you're a math magician, you have certain tricks. It's not really magic, but there are tricks for ways to solve this. And we are going to use the trick of multiplying by 1, putting it in a 1 costume. And my 1 costume, it's a pretty fancy one. It's secant theta plus tangent of theta over secant theta plus tangent of theta. And I like 1 costumes because they change what something looks like without changing what it actually is. So when I distribute in my secant theta, I now have secant squared theta plus secant theta tangent theta. Maybe this is a little bit familiar in the vast recesses of your brain, plus tangent of theta d theta. And now, using our amazingly increased W substitution skills where we don't actually write out our W, I can see that the top is the derivative of the bottom. And so if we did a W substitution, we're really looking at a 1 over W dW, which of course our antiderivative is ln of W, which in this case is our secant theta plus tangent theta. And then we have our at a constant, labeled C. All right, so ln of secant theta plus tangent theta, the absolute value. Because that will get me secant theta plus tangent theta on the bottom, and the derivative of secant theta will get me my secant theta tangent theta, and the derivative of tangent will get me my secant squared theta. So, are we done? Well, that is the question. And the question is, of course, not yet. These are the problems that never end. Our solution is in terms of theta, and we need it in terms of x, because when we started, we had a problem that was all about x. So I know that x equals 7 tangent theta. So I'm going to draw a little picture. X is 7 tangent of theta. That makes tangent of theta equal to x over 7. So if here's my theta in my little right triangle, x is my opposite, 7 is my adjacent. My hypotenuse, and this is where the 49 plus x squared, the square root of that, comes from. So now I'm going to use my picture to get values or ratios for secant of theta and tangent of theta in terms of x. So I replace secant of theta, which is the reciprocal of cosine. So instead of adjacent over hypotenuse, I'm going to do hypotenuse over adjacent. And then tangent of theta is opposite over adjacent. Plus c. And there, I have solved this integral. All right. Let's try the next one. So here we have a problem that's remarkably similar with a little bit of difference. We still have our 49 plus x squared, the square root of that. And so I still see that, and I think, normally I would think of a w substitution with something on the inside, but this is not a w substitution because of this very special square root. So we're going to make x equal to 7 tangent of theta, which still leaves dx as 7 secant squared theta d theta. And now when I substitute in, I get something different. So my top is the dx, 7 secant squared theta d theta. This is sort of like deja vu. I get my x, which is a 7 tangent of theta, and I get my root of 49 plus 49 tangent squared theta. And again, you can jump from this to replacing your root, 7 tangent of theta, with a 7 secant of theta. You do not have to work this all out. Oops, I lost the 49 in here. But I get 7, this part right here is the same as 7 root 1 plus tangent squared theta, and 1 plus tangent squared theta is secant squared theta, and the root of secant squared is going to be secant. So now I can do a little canceling. The 7s will cancel. This secant cancels one of these secants. So now I have a slightly different integral than what I started with, or than what I had in the last problem. If the top was a secant squared, that would be nice, because that would be the derivative of tangent, and this would be a w substitution. But alas, it is not. So I have to try something else. And a big thing, this whole unit is all about replacing something with something else that is the same but looks different. And so I'm going to go old school. We haven't done one of these. I'm going to replace secant theta with 1 over cosine theta, and tangent of theta with cosine theta, sine theta over cosine theta. And I still have my d theta. And now with a fraction divided by a fraction, right, I multiply by the reciprocal, so I have 1 over cosine theta times sine theta times cosine theta over sine theta d theta. And now my cosines will drop out, and I'm left with 1 over sine, which we know as cosecant of theta d theta. Again, cosecant squared theta would be a nice basic antiderivative. However, it is not. And so we're going to trick ourselves again in similar fashion to the last problem where we had a secant theta. Now we have cosecant of theta. We're going to multiply by our very pretty one costume of cosecant theta plus cotangent of theta. I still need my d theta. Remember, your d thetas are important. Distribute and get cosecant squared theta plus cosecant theta cotangent theta all over cosecant theta plus cotangent theta. And at this point, if you wanted to try and finish this problem out yourself and then check the video, that would be a good idea. Or earlier, you could try that too, although it's too late now. So let's keep going. This is now a W substitution with our W being our bottom. And if we take the derivative of the bottom, we get the top, which makes our antiderivative with our amazing dub sub skills now, ln of cosecant of theta plus cotangent of theta plus c. And we are still not done. We still have to get rid of theta and get back to x. And back from the beginning, we have a similar picture to last time, which had our theta, and we had x was 7 tan theta. Here's my x, here's my 7, here's my square root of 49 plus x squared. So ln of absolute value, the cosecant of theta is 1 over the sine. So instead of opposite over hypotenuse, it is hypotenuse over opposite. And cotangent is adjacent over opposite plus c. And there you have it, trig substitution when we're starting with square root of a squared plus x squared.